Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. Hello, how are you today? Today we will learn about sequence and series. We already learned about sequence and series in the previous meeting about introduction to the number sequence and about arithmetic sequence. But today we will talking about arithmetic series. So, what is arithmetic series? Arithmetic series Arithmetic series often when we have a sequence of the numbers and we wish to know their sum, it's called its arithmetic series. So arithmetic series is the sum of an arithmetic sequence, everyone. So in arithmetic series, we divide it by two. The first about sum of the first n term and the second about the apply problem. So now we will talking about sum of the first n terms. For some of the first n terms, let us consider an arithmetic sequence whose first few terms are. We have the first term 3, the second term is 7, the third term is 11, the fourth term 15, and then the fifth term is 19. And then we curious what's the sum of the first term? Obviously 3, yeah, right? And then we want to know about the sum of the second term is 10. Why is 10? Because 3 plus 7. And then the sum of the three terms is 3 plus 7 plus 11, and so on. Or I can, in some of the first n term, we can denote them b as n, or the call is the sum of the first n terms. So the sum of the first n term have a formula is Sn equal the first term plus second term and so on until the n terms. And then when we want to try to answer this question 3, 7, 11, 15, and 19, we can write S1 is 3, and then as the first two term is 3 plus 7, and then so on until S5. Now, okay, everyone, we have question given an arithmetic sequence with the general term En equal 3n plus 1, find the sum of the first three terms. So from here, we need to find the first term. The first term is that the meaning the n is equal 1, right? So you can substitute the n equal 1 to 3 times 1 plus 1 is equal, right, is 4. And then the second term is equal 3 times 2 plus 1, so it's equal 7. And then the third terms is equal 3 times 3 plus 1 is equal 10. Because they're talking about find the sum of the first three terms, so we can write it in here, the first term plus the second term plus the third term. So we can rewrite plus 7 plus 10 is equal 21. So in here it's easy, yes, because they're just asking about the first three terms. Could you find the first 100 terms? So from here we can using formula after this. Now the theorem. The theorem of the sum of the first n term of an arithmetic sequence is Sn equal the first term plus general terms over 2 times n. So here we want to prove about this formula. We already know in the previous slide if Sn is equal the first term plus second term plus dot 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 until the general term. Or we can write again to be Sn equal general term plus n minus 1 terms plus blah 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 until the first term. So from here we can adding the both of them to b. So from here we can see 2Sn equal the first term plus general term, the second term plus the n minus 1 terms dot until general term plus the first term. So from here we can change. We already know if the an minus 1 is that the meaning en minus d. So from here you can continue until to get to Sn equal the first term plus n term plus is the same format, so we can continue to be n terms, n times, everyone, sorry. So from here we can continue to Sn equal the first term plus En times n, and then so the formula of the arithmetic sequence for the sum of the first n term is Sn equal the first term plus En over 2 times n. So now we will continue to the example. Example, given an arithmetic sequence with the first term is 3 and then the seventh term is 15, and then you need to find S6. Okay, remember of the Sn is equal the first term plus the n terms over 2 times n, everyone. So from here, you already know the first term is 3 and then the seventh terms is 15. So the first you need to find D. Okay, so to find D, you can using the seventh term. Seventh term is the first term plus 7 minus 1 times D. The seventh term is 15. The first term is 3 plus 6D. Right? So from here, 15 minus 3 equals 6D. So 12 over 6 equal D. So we got the difference is 2. So from here, we need to find, because they are taking 6 as 6. So the first term plus the sixth term over 2 times 6. So we need to find the sixth term. So we need to find the sixth term. So from here, we get the sixth term. Sixth term is equal the first term plus 6 minus 1 times D, right? So from here, you can write the first term is 3 plus 5 times D is 2. So the sixth term is 13. So we just need to substitute all of them to be, the first term is 3, the sixth term is 13 over 2 times 6. 6 cancel with 2 is 3. So 16 times 3 is equal 40x. So this one is the value for the find for S6 term, everyone. Example number 2, given an arithmetic sequence with the first term equals minus 6 and the difference 3, and you need to find S18. So in here, we know S18 is the first term plus the 18 terms divided by 2 times n, everyone. So from here, we need to find the 18 terms. 18 term is the first term plus n minus 1 times D. So the first term is minus 6. So plus 18 minus 1 times D. D is 3, right? So this one is minus 6 plus 17 times 3. So minus 6 plus 251. So this one equal 55, right? The 18th term is 45. So we just need to substitute all of the value that we have to here. So the first term is minus 6 plus 45 divided by 2 times 18. So from here, we can cancel 18 with the 2 is to be 9. So 45 with the minus 6 is equal 39 times 9. So let me calculate first. 39 times 9, 18, 35. So in here, the value is, this value is 351. So the value for the S18 terms is 351, everyone. Given an arithmetic sequence with the first term is 66 and then the 15 terms is minus 18, you need to find S20. So S20 is equal the first term plus the 20 terms over 2 times 20, right? But before we answer this one, we need to find the difference first. So we have the 15 terms is equal minus 18. So the first term plus 14 minus 1 times D. So the 15 terms is equal minus 18, and then the first term 66. So this one is 13 times D. Oh, sorry, this one is 15 is equal 14 times D. So from here, we have is minus 84 is equal 14D. So we have difference is minus 6, right? So from here, we can continue to find the 20 term is equal the first term plus 20 minus 1 times the difference. So the first term is 66 plus 19 times minus 6, right? So from here, I want to continue to calculate first. Okay, 144. So this one is equal 66 minus 114. 66 minus 8, 4. So this one is equal minus 84. So from here, we can continue to the S20. But before we continue, we can cancel in here 20 and 2. So this one is equal 10. So S20 is equal the first term plus this 20 terms times 10, right? So the first term is 66, and then the 20 term is minus 40x times 10. 66, 16 minus x, 8, 5 minus 4, 1, 10 times is equal 180. So this one is the way how to solve this question. Okay, now another example. If minus 12 plus blank 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 plus 80x is equal 79x is the sum of the terms of finite arithmetic sequence. How many terms are there in the sequence? So we know that if the sum of the term is Sn is equal the first term plus En over 2 times n. So from here we have the first term is minus 12, and then the nth term is equal 18. So we just need to substitute all of the what they given to us. 79x is equal, sorry, this one is minus. So in here minus 12 plus 80x over 2 times n. So 79x is equal 6817 over 2 times n. So here 79x is equal 30x n. So n is equal 79x over 30x. So it's equal 21, right? So I hope you understand what I'm explaining. We have alternative sum formula. So the sum of the first n term of an arithmetic sequence is Sn equal to times the first term plus n minus 1 times d over 2 times n. So in here we want to prove, is it true? Because in the definite or the theorem of the sum of the first n term, we want to make it easier for us. So we change En with the general terms with the first term plus n minus 1 times d over 2 times n. So here we can simplify this one. We can say the formula is 2 times the first term plus n minus 1 d over 2 times n, or n over 2 times the first term plus n minus 1 times d. Okay, now we continue to another example. Given an arithmetic sequence with the first term equal minus 4, and then the S12 is minus 246, and then you need to find D. Okay, we can using the alternative formula. Okay, alternative formula is Sn equal 2 times the first term plus n minus 1 times d over 2 times n, everyone. So Sn, because we are talking about the n is 12, so S12 equal 2 times the first term plus, okay, let me continue to change in here. So I just want to substitute everything times minus 4 plus 12 minus 1 times d over 2 times 12. Okay, 12 and then 2 is equal to be 6, right? And then in here we can continue to be minus 246, and then forget using the bracket in here. So it's equal minus 8 plus 11d times 6. So the both of side we can divide it by 6. So 246 divided by 6 is okay, not to divide it, everyone. So we just continue. So to be, we cancel this one. So in here, minus 246 equal minus 48 plus 66d, right? So in here, minus 246 plus 48 is equal 66, is d is equal minus 198 equal 66d. So d is minus 198 over 66 is equal, I think 3, 19x divided 3, 318, 119. Yes, this one is the difference is 3. So we get the difference is 3, everyone. Given arithmetic sequence with d is 6 and then S10 is 20, you need to find the first term. So we can using the the alternative formula is Sn is equal 2 times the first term plus n minus 1 times d over 2 times n. Okay, so in here, S10 is equal 2 times the first term plus 20 minus, oh not 20, because we're just talking about 10, sorry, that's my fault. So in here we can 10 minus 1 times d, and then d is 6 over 2 times 10. So from here we can cancel the between of 2 and then 10 to be 5. So S10 is 20, 2a1 plus 9, this one is 9 times 6 is 54 times again with 5, but we can cancel 20 and 5 to be 4. So in here 4 minus 54 is equal to a1, so minus 50 over 2 is equal, the first term is minus 25, everyone. I hope you understand what I'm explaining. Okay, we already tried to solve the problem. Now you have exercise, everyone. Okay, you have exercise from the sum of the first n terms. Okay, what's the exercise? You need to solve the 7 all of them in your diary books. If you don't understand, you can contact me on my WhatsApp number or in this video. So, okay, next we will talking about how apply the problems. Okay, how apply the problems. So in here, for the apply problems, okay, sorry. Okay, the apply problem. Okay, now example for the apply problem. Okay, a factory produce 1960 unit of an item in the first year. So we can write the first years is equal, the first terms is equal 1960 unit, and then the production is decreased by minus 120. So we can write difference is minus 120. Unit is until 16 years. So this one is called and is equal 16. They told us the total amount of production until 16. So this meaning you need to find S16 everyone. Okay. So from here we can using the alternative formula S16 equal 2 times the first term plus 16 minus 1 times the difference over 2 times 16. Okay, from here we can cancel 16 and 2 to be 8, and then we can substitute all what we have as 16 equal 2 times 1960 plus 15 times 120 close bracket times by 8. Okay, so from here we simplify in this bracket. So this one is to be 0, 2, 1, 18, 19, 1, 3, and then minus 15, 12, 0, 1, 3, 5, 1. So this one is 118 is times 8. So 3, okay, 118. So 0, 2, 1, 2, right? So this one is equal to 2120 units time by 8. So here 8, 0, 16, 1, 9, 6, 16. So this one equals 16 times 6 and 960 everyone. A man climbing up a mountain climb in 800 meters in the first hour. So this one it's meaning the first time is 800 meters, and then 25 meters less than the previous hour. So that's the meaning the difference is minus 25. And then in how many hours he can climb in 5,700 meters. So in here they're talking about the Sn is equal 5,700, and then they ask how many hours, and it's meaning that hours. So from here we can using the alternative formula. So Sn equal 2 times first term and minus 1 times d over 2 times n everyone. So from here we can substitute everything that we have. 5,700 times 2 times 800 times and minus 1 times minus 25 over 2 times n. Okay, from here I recommend that you are using bracket to make it rank is the percentage of the rank is little bit. Okay, so from here you can times in the both side times by 2. So this one is to be 1,000. This one equal 1600 minus 25n plus 25, and then this one times by n. So this one 11 times 400 equal 1625n minus 25n squared. Okay, so from here you need to make the one side to be equal 0. So 25n squared minus 1625n, and then plus 11 400 equals 0. Okay, the both side we divided by 25. So this one equal n squared minus 1625 divided by 25 is 5. 50, 50, oh no, 6. So this one is equal 150, and then 1 to 5. So this one is 5. Yeah, so this one is 65n plus 11400 divided by 25 is 4. 100, 400 is by 3. So not 3, but this one is 5. 5 is 1 to 5 is 15. Is 25, 5, 6, right? 4, 6, 4, 5, 6, 0. And n square minus 65n minus 65n plus 4, 5, 6, 0. Okay, so we need to fraction, or not fraction, we need to factorize the both of them to be n minus 57 and minus x equals 0. 57, 65. Okay, so this one is 8 is equal 57, or n equal x. So from here we have n equal 57 and we have n equal x. So what's the most probability to the value is 700? So I can using S8 to B. We want to check we want to know what's the n we want to using. So 2 times the first term plus 7d over 2 times 8. We can cancel the both of them to be 4. 2 times the first term 800, and then plus 7 times minus 25, and then we close bracket times 4. This one is 16 minus 175 times by 4. 116, 175 is 5925, oh no, 4. Okay, so this one is 1425 times by 4. We need to times by 4. Times by 4 is 0, 2, 8, 9, 10, 1, 16, 17, 1. Okay, so this one is equal 507,000. 5,700. I mean, so the n we will use is n equal 8, everyone. Okay, we already have okay, we already talking about the sum of the first n term and then the apply problem. So you need to do exercise, everyone. So please open your Jambox book, page 32 until 35, and answer, check yourself 8. Okay, that's it for what I'm explaining today. I hope you enjoy. For the next meeting, we are talking about geometric sequence. So thank you. Assalamualaikum warahmatullahi wabarakatuh.